Hello students, in today's video we are going to be working on implicit differentiation in your calculus class. So let's get started. Go ahead and try this warm-up problem. This would be a great time for you to pause your screen and try working this out on your own. Hopefully you've paused your screen and you're just coming back to check your answers. Now, keep in mind this problem looks a lot more complicated than it should, but it's just to make sure you know what you're doing. So first things first, I'm going to rewrite this and we are going to use the chain rule. So keep in mind that as we do this, the problem is exactly the same, but I am rewriting it so that this looks much easier for you to do in a little bit. So I rewrote these problems and I put the exponent on the outside. Keep in mind when we do this, we're just doing the product rule and we're combining it with the chain rule. So because this is a product, remember we are doing the derivative of the first times the second. So to do that, we are going to do the chain rule on this specific portion first that I've highlighted. So first things, we're going to bring down that 9. We're going to keep the inside exactly the same. And because we use the power rule, we're going to make this to the 8th power. Now because we're also using the chain rule, we are having to find the derivative of the inside. So the derivative of sine 3x minus 2 then becomes cosine of 3x minus 2. And again, because this is the chain rule, we're going to now take the derivative of the inside, which is 3. So that's the derivative of the first times the second. So that's the first part, derivative of the first times the second, plus the derivative of the second times the first. So we'll go ahead and write down our first. Notice I'm just copying and pasting from the top line. And the derivative of the second portion was 5 cosine 7x to the 3rd power to the 4th. And because we still did the power rule, we're doing the chain rule as well. So now we're doing times negative sine of 7x to the 3rd power times the derivative of the inside of that, which would now be 21x squared. So it's a very big problem, complicated, but again, if you do it in pieces and you just stick to the rules, you should be just fine. We're not going to simplify it because I just wanted to test you and show how we incorporate those 3 rules. So, getting back to implicit differentiation, what we wanted to do is discuss what that looks like. Now, implicit differentiation is used when it's not possible or not practical to solve for y. And in that case, we're going to differentiate both sides, treating y as a function of x. So when we do that, we solve for dy dx. And one last thing about the power rule, it works for rational exponents, works for radicals, which you've already seen in some of our previous examples. So now let's do some implicit differentiation using example 1. So you'll notice here that they just want us to find the derivative. So the way that this works is by taking the derivative of each. So the derivative of x cubed is 3x squared plus 3y squared dy dx. So what you'll notice here is when we took the derivative of each piece, we took the derivative of y and we wrote dy dx right next to it. So for 18xy, it's going to be the product rule. So we're going to leave that 18 in front, and then we're going to write xy here. So the first portion should stay exactly the same. And then when we do our derivative of the first is 1 times y plus derivative of the second. So derivative of the second is dy dx times the first. So simplifying, we get 18y plus 18x dy dx. Next thing we do is we move all the dy dx's next to each other, and we move everything else away from it. So we're going to go ahead and subtract 3x squared to both sides. And we're left with 3y squared dy dx. We're going to subtract the 18x dy dx to both sides, so we get minus 18x dy dx equals 18y minus 3x squared. Now we're going to factor out the dy dx from both sides. So we get dy dx times the quantity 3y squared minus 18x equals 18y minus 3x squared. Now we're going to divide the entire 3y squared minus 18x to both sides. So we're left with dy dx equals 18y minus 3x squared, all divided by 3y squared minus, 18y, oh no, I was right, divided by 3y squared minus 18x. And now we've solved for dy dx. So let's go ahead and look at another example. Now we're going to find dy dx for this slightly more complicated problem. So again, to find the derivative of this using implicit differentiation, it's the same exact idea. It shouldn't be too difficult because we're just incorporating some of our past rules. So derivative of 2x or of x squared is 2x minus 7. Remember, we do the derivative of the first, so that's 1 times y, plus derivative of the second, x times dy dx, plus 2y dy dx equals 2. So again, we're left with 2x minus 7y minus 7x dy dx plus 2y dy dx equals 2. We're going to go ahead and subtract the minus 2x and plus 7y to both sides, so we can move that to the other side. So that was a minus 2x plus 7x. We're left with negative 7x dy dx plus 2y dy dx equals 2 minus 2x plus 7y. I wrote x earlier, sorry, I meant y. Now we're going to factor out dy dx again, times negative 7x plus 2y equals 2 minus 2x plus 7y. Now we're going to divide negative 7x plus 2y to both sides so we can isolate the dy dx. And we're left with dy dx is equal to 2 minus 2x plus 7y, all divided by negative 7x plus 2y. And again, implicit differentiation shouldn't be that bad. We're just incorporating our rules. Anytime we take the derivative of y, we add the dy dx, and then we want to isolate it from everything else. So let's try another quick problem. Again, if you think you get the hang of it, this would be a great time for you to just try it on your own, fast forward, and then double check your answers. So the next one should be 4x plus 5 times derivative of the first times the second plus derivative of the second times the first. So dy dx times x minus 6y dy dx equals 2x plus 6 dy dx. Notice I've been putting all the dy dx's in parentheses because it just makes it easier, and I want to make sure you all see it. So this simplifies to 4x plus 5y plus 5x dy dx minus 6y dy dx. I'm going to subtract the 6 dy dx to both sides equals 2x. Now I'm just moving everything over. So that is going to leave us with 5x minus 12y dy dx equals 2x minus 4x minus 5y minus, that's it. So I'm going to simplify and divide, so I'm going to get dy dx equals negative 2x minus 5y, all divided by 5x minus 12y. So that's that problem. So we're going to find the slope of the circle at the indicated point. So now we're trying to find the slope of the circle at the indicated point. So remember, when we find the slope, we're really just finding the first derivative and then going from there. So we're going to go ahead and use some implicit differentiation here. Notice we have what looks like something where we could use the chain rule. So we're going to take the derivative of the outside. So as I move the 2 exponent to the front, subtract that by 1, and then we are going to multiply by the inside. Same thing for the y's. So that's y plus 3 times y, times dy dx, because the derivative of y is just 1 dy dx, equals 0. Now we're going to go ahead and isolate the dy dx by moving everything over. So now that gives us 2y plus 6 dy dx equals negative 2x minus 4. Now we're going to divide by 2y plus 6 to both sides. We get dy dx is equal to negative 2x minus 4, all divided by 2y plus 6. Now we're trying to find the slope at that specific point. So dy dx equals negative 2 times 1 minus 4, all divided by 2 times negative 7 plus 6. We get dy dx is equal to negative 6 divided by negative 8. Final answer here, we get dy dx is equal to 3/4. So notice there, all we did is we substituted the x and y values in after we found dy dx, and we know that the slope there is 3/4. So this is a chance for you to try it. I'm going to go ahead and solve it really quick. Again, pause your screen, try it on your own, and then double check your answers. So this turns out to be the following. We isolate the dy dx, we end up getting dy dx is equal to negative 2x divided by 2y. Dy dx is equal to negative x divided by y. And finally we get x is equal to negative 0 divided by 3. And finally your final answer is 0. So in this case, we're going to try and find out where the slope of the curve is defined. So basically here, we're just finding the derivative and solving for dy dx. Tells us what our answer is, and then it lets us know at whatever point we decide to substitute if it exists. So let's try that. Again, at this point, I'm hoping that you're getting much faster at this, so I'm kind of skipping a few steps. Remember, 4xy becomes derivative of the first times the second. So 1 times y plus x times dy dx plus 8y dy dx minus 3 equals 0. We get 2x plus 4y plus 4x dy dx plus 8y dy dx equals 3. I'm going to move the 3 to the other side already. I'm going to move everything else over and factor out. So we get 4x plus 8y times dy dx equals 3 minus 2x minus 4y. Then we're dividing by 4x plus 8y to both sides. So dy dx is equal to 3 minus 2x minus 4y, all divided by 4x plus 8y. And so this gives us the slope where the curve is defined. So now, so long as our derivative, or so long as our denominator isn't equal to 0, then our slope will always exist. So let me make sure I repeat that one more time. This function right here will give us the function for our slope, or the value for our slope. The only time where it will be undefined is if 4x plus 8y is equal to 0, because then your function would be undefined. So, same thing here. Find where the slope of the curve is defined. Again, just doing derivative. So, derivative of x is 1 equals, this is chain rule now, so we're going to take the derivative of the outside. Derivative of cosine is negative sine of y. Derivative of the inside, which is y, is now dy dx. If we wanted to isolate dy dx, we would divide by negative sine y, so we're left with 1 divided by negative sine of y. So, this function, or the slope, is defined at any value of y where your negative sine y is not equal to 0. So, something like y of 0 would make this undefined, but this is enough for now. So long as you know that negative sine y cannot be equal to 0, then the curve is defined. So find the equation of a line tangent to the following function at negative 7 at 1, negative 2. So remember, let's go ahead and find the equation of the line. So let's find the derivative first. This gives us 3x squared plus 3y squared dy dx is equal to negative 7. We get dy dx equals negative 7 minus 3x squared, all divided by 3y squared. So dy dx is equal to negative 7 minus 3 times 1 squared, all divided by 3 times negative 2 squared. And we find that dy dx is equal to negative 10 divided by 12, which means dy dx is equal to negative 5/6. So now we found the slope of the tangent. So we found the slope of the tangent. Now we need to find the equation, right? So we're going to go ahead and put in y minus y sub 1 equals m times x minus x sub 1. So they already gave us our x and y values, so we're going to go ahead and substitute those in. Equals negative 5/6 times x minus 1. We get y plus 2 equals negative 5/6x plus 5/6. We're going to subtract 2 to both sides to isolate the y. We're left with y equals negative 5/6x. So we found the common denominator here. That's going to be negative 12/6. So that's going to give us negative 7/6 as our final answer. So let's try another one. Here, you already know what we did. First we found the first derivative, then we found the tangent slope, the normal, slope, and we substitute those values in. So we'll do this one really quickly. So 2y dy dx minus 2 minus 4 dy dx equals 0. We're going to add 2 to both sides. We're left with 2y minus 4 dy dx equals 2. Dy dx is equal to 2 divided by 2y minus 4. Dy dx is equal to 2 divided by 2 times 1 minus 4. And finally, dy dx is equal to 2 divided by negative 2, which is equal to negative 1. So now we found the slope of the tangent. Remember, slope of normal is the negative reciprocal. So it's already negative, so another negative makes positive. We flip it over, it just becomes positive 1. And then you can put that into your point slope form. Next one. So find the equation of a line tangent and normal to the curve at the point. So again, we'll go ahead and find the slopes just to make sure you have enough practice doing these implicit differentiations. Notice we have a product rule on the left side. So derivative of the first times the second plus derivative of the second. So derivative of the second is chain rule, so we take the cosine. 2y, we take the derivative inside. So derivative of 2y is 2 dy dx times the x equals derivative of the first, so dy dx times the second plus derivative of the second. Derivative of cosine is negative sine 2x times derivative inside, which is just 2, times the first, so that's just y. So cleaning that up, we get sine 2y plus x cosine 2y. Actually, I'm going to pull up the 2 right next to the dy dx over here as well. So that becomes 2x cosine 2y dy dx equals dy dx cosine 2x minus 2y sine of 2x. Again, we're moving all the dy dx's to the left and everything else to the right. We end up getting negative cosine 2 of x plus 2x cosine 2y dy dx equals negative 2y sine 2x minus sine 2y. Now we're going to divide to isolate the dy dx. We're left with dy dx is equal to negative 2y sine 2x minus sine 2y, all divided by negative cosine 2x plus 2x cosine 2y. Substitute those x and y values in, the pi over 4 and pi divided by 2, and finally you would be done. So hopefully that helps. I know it was a little dry, but I wanted to make sure you had easy, medium, and spicy problems to practice on. But that's all for now. I'll see you guys next time.